Okay, so here's derived rule 8. It's a certain equivalence. So this will be a good example to show you how we prove an equivalence when I try to prove derived rule 8. So this one is titled Conjunction and Implication, because it's sort of showing you the interaction between conjunction and implication. And I hope that you can make it intuitive for yourself somehow. See if you can make it feel right. So maybe try to fill in specific propositions in for phi, psi, and omega, and see if it feels right that this statement really is the same as this statement. After all, that's what an equivalence is trying to say, that this holds or fails precisely when this holds or fails, respectively. Okay, but regardless of whether you feel that they're the same, let's dive into a proof. So, what am I trying to prove? An if and only if, a logical equivalence. So then, we look here at equivalence, how to prove both implications. So to prove that phi holds if and only if psi holds, I must prove phi implies psi and psi implies phi. And if I go up here, this is sort of the template that I would be following to prove both implications. All right. So that means my proof is going to split into two parts, the this way part and the that way part. And I should make them maybe two separate paragraphs. It's basically like I'm writing two proofs of two different things. One way to organize things is to write them as separate claims. So I could say, maybe I can copy and paste to make this go a little faster. Never mind, let me just rewrite it, but smaller. So we have two claims to prove. Claim 1 is that the left side implies the right side. So if the left side holds, then the right side holds. And basically I've just rewritten what's up there, but with a single arrow. And then claim 2 will be the same thing, but with the arrow flipped around. All right, so here's the proof of claim 1. So this is a proof of something inside a proof. And anytime you want to structure your proofs like this, you can put little proofs of things inside them. And you don't have to number your claims always like I'm doing. You can just write claim. But sometimes it's nice to number claims so you can refer back to them later on. Okay, so what am I proving for the sake of claim 1? I'm proving an implication. And that means I'm going to do this. Assume the hypothesis and then try to prove the conclusion. So assume the left side, which is this part, and then try to prove the right side. So assume that phi and psi implies omega. Now my goal is to prove this. So if my goal is to prove this implication, then what must I do? Same deal. To prove an implication, assume the left side and then try to prove the right side. So I'm going to assume this and then try to prove this. So assume that phi. So this first sentence, this first assumption, is for the sake of proving this implication, and the second assumption is for the sake of proving this implication. Now my goal is to prove this implication, right? So to do that, same deal. I assume the hypothesis. Assume that psi. So I'm assuming this. And now my goal is to prove this omega. So at each stage after I make an assumption, I have a goal in mind. So there's sort of like this unwritten part. Like here, I'm not writing it in the proof, but I'm thinking it. I'm thinking, goal is to prove phi implies psi implies omega. And here, right after I say it, I'm thinking, I'm not writing it, but I'm thinking the goal is to prove psi implies omega. And here, after I write it, I'm thinking, okay, now the goal is to prove omega. So often people are not writing their goals, but it's good to have it in your brain or on scratch paper. Usually for complicated things, you really need to have it on scratch paper. All right, let's continue. So now the goal is to prove this omega over here. Well, all I have to do it with is these two things, which I don't see what to do with yet, and this thing, which is an implication. How do I use an implication? It's this modus ponens thing. To make use of an implication, I need not only the implication, but I need to know that the hypothesis is true. Then I can use it to conclude the conclusion. So if I want to use this, then I need to know that phi and psi is true. Do I know that phi and psi is true? Well, I know that phi is true, and I know that psi is true. So then I do know that phi and psi is true. Since phi and psi are both true, and phi and psi, let me write this in extreme detail mode. Since phi and psi are both true, we have phi and psi. So what I'm using here is this idea that if you want to conclude a conjunction, if you want to get phi and psi, then you must prove phi and psi. So this is a little bit weird. You have to prove phi, and you have to prove psi, and that will be a way to prove phi and psi. So see how this and is a little bit different than the and here. So since we have phi and we have psi, it follows that we have phi and psi. Often this step is such a fine-grained detail that we just wouldn't write it. But at this stage, I'm writing it since we're at the level of caring about those kinds of details. Okay, so now we can apply modus ponens. Since phi and psi, and we also have phi and psi implies omega, we have omega. And that finishes the proof of that claim. I'm not going to put a box though, because we're inside a larger proof here. And if I put a box, that would suggest that the overall proof is finished. So remember, the box means that which was to be proven has been proven. But it's not the claim that was really to be proven, it's this original derived rule 8. So it's only the claim that's finished. So I'm just not going to put a box. Instead, I'm going to start with claim 2. The fact that I'm starting a new claim suggests to you that the proof of claim 1 is finished. Okay, so claim 2, that's going to be the same as claim 1, except with the arrow going the other way. So this. Okay, so there's the statement of claim 2, and you see it's the same as claim 1, but just going the other way. So if I look back at what I was originally trying to prove, it's this, but with this arrow here is now what I'm working on. Okay, so now what I'm trying to prove is an implication, right? That something implies something. So I'm not going to keep going back to the table. Let's just go ahead and do it. Assume the hypothesis. So assume that phi implies psi implies omega. And now I'm thinking to myself, but not writing, that this is my goal, is to prove that. Okay, well, what kind of thing is this? Is it a conjunction because of this and? No, it's an implication. You have to pay attention to the parentheses, right? So this is an implication, so to prove it I should assume the hypothesis and then prove the conclusion. So assume that phi and psi. Now, from phi and psi, I can deduce, from something like phi and psi, I can deduce phi and I can deduce psi. So, then phi. In particular, I can deduce phi. And I want to do that because that will allow me to use this implication. This is modus ponens again, right? I need the hypothesis, and I have it. So, since we had that implication up there, we have the conclusion of the implication. Great. So, what was the goal again? I've kind of forgotten. So, what are the unspoken goals? When I made this assumption, the goal was to prove this, right? Then when I made this assumption, that was for the sake of proving this implication, so the goal becomes to prove this. So here, the goal is prove that omega is true. Okay, so keeping that in mind, what have I achieved so far? I've got psi implies omega. Okay, so if I prove psi, then I'll get the omega that I want. So let's see if I can prove psi. Well, I already have phi and psi, the conjunction. Therefore, I can deduce phi and psi individually. Since phi and psi it follows, let's just say we have psi. Then it follows from the implication psi implies omega that omega. And that finishes the proof of claim 2. And with claim 1 and claim 2 together, that finishes the overall proof, since we proved both the implications needed to prove this equivalence over here. So now I can finally put the box at the end of everything. And that's derived rule 8. So I want to make a couple of comments. I already made a comment in claim 1 about how we normally wouldn't make this super fine detailed step. There's another fine detailed step here in claim 2. So here I said assume that phi and psi, right? Now, technically that's different from saying assume that phi and assume that psi. That's technically a different thing. But and here we've cared about the distinction. But normally that's such a fine-grained detail that we just sort of skip it over. We don't really care about the difference between assume phi and psi and assume phi and assume psi. They're so immediately linked from phi and psi, you can immediately deduce phi and psi individually. So we don't really care about that detail normally. And another point, so I've organized this by claims. So I've organized the proof of this if and only if by writing, by making one claim be one arrow and the other claim be the other arrow. Another way to organize things is just by paragraphs. So I could have made this one paragraph, claim 1, and then down here make claim 2 another paragraph. Then to help make things clear, if I'm not going to state the claim that I'm proving so clearly like I did here, what I can do is put some headings in front of the paragraphs, kind of like this. So here, instead of a claim, I can put a heading. I can just make this its own paragraph. And then maybe I can say, okay, this is the proof of the forward direction arrow. So proving that this thing implies this thing. And then down here, I can say, okay, now this is a new paragraph, so I've left a gap here. And now I'm proving so I'm putting a backwards implication symbol to say, okay, now I'm proving that direction. So this means I'm going to assume the right side up here and then prove the left side. So these are just different ways of organizing what you're writing.